Welcome, Hornets. I am Mr. Lamb, and today we are going to begin by going over the first section in our textbook. This is working with models and graphs and represents a basic review of Algebra 1 and Algebra 2. Therefore, in this section, we're going to be discussing even functions and odd functions. We'll be discussing symmetries, multi-roots, and x-intercepts, y-intercepts, domain, and range. So let's go ahead and begin. First of all, when we're talking about even functions, we're talking about symmetry through the y-axis. So we are talking about symmetries. Graphs of even functions will always be symmetric to the y-axis. That means that if I have a point on the left side, which is negative xy, there has to be a mirrored image through the y-axis, and we'll identify that mirrored image as x comma y. Now, we know this function is a basic function. Every x has only one y, but it is not one-to-one. A one-to-one function, like a line or a cubic, specific cubics, have for every one x, there is only one y value. And you'll notice that here we have two x values for one y value, and this will breach what is called the horizontal line test. So one-to-one functions satisfy the horizontal line test as well as the vertical line test, and functions satisfy the vertical line test. Types of even functions are any function that has even exponents only. Notice in this problem right here, I have only even exponents. And because I have only even exponents, if I plug in a negative x, I will end up with the original equation. That's the test for an even function. By plugging in a negative x, you end up with the exact same function again. Please be aware, anytime you have functions that have only even exponents, you will have a symmetry to the y-axis, and you are looking at an even function. Odd functions, however, are slightly different. They now have a symmetry not to the y-axis, but to the origin. And because they have symmetry to the origin, that tells me that if I have a point in the first quadrant that is a positive x, positive y, it will have a mirrored image in the third quadrant, which is negative x comma negative y. Now, according to our testing, an f of negative x will result in the negative f of x. Notice you plug in a negative x, you get a negative y value. Okay? This is very important to us. Please remember that any function that has only odd exponents will be an odd function and will have symmetry to the origin. Now we have to be very careful, ladies and gentlemen and gentle folks, hornets, because when we start talking about rational functions, such as f of x being made of two functions, one in the numerator and the denominator, it often helps to think about the odd function as having a negative result. That's because the negative comes out from the f of x and it gives me a negative f of x. So if that's the case, then I can look at the odd functions in a numerator as being equivalent to a negative, and an even function in a denominator can be represented as a positive. Now notice a negative over a positive is a negative result, and as a result, as a consequence, we would say that an odd function over an even function is an odd function. So I like to look at it as odd over even is odd, even over odd is odd. Notice that the two functions are in essence opposites. So one of each category of symmetry. If they have the same symmetry, odd over an odd, that's the same thing as having a negative over a negative, which would be a positive and therefore even. An even over an even function is the same thing as a positive over a positive, which would be a positive, and therefore also even. So when we're looking at even and odd rational functions, we're looking at what is the function in the numerator and what is the function in the denominator separately. We then put them together and then determine the result. Thank you very much, gentle folks. We will be going over intercepts in our next lesson. Thank you.